Hello and welcome back. In this lesson, we're going to start looking at arrays, and arrays are sort of like a drawer. You organize them, you put things in them, you take things out of them. That's basically what an array allows you to do. Sometimes you just need a way to put lots of data into a particular area. Now, JavaScript does not have what are sometimes called hashed arrays or associative arrays or hash maps or whatever your particular language calls it, arrays that can be identified by a key. Instead, the only thing that JavaScript has are what are known as indexed arrays, which means numerically indexed arrays are 0, 1, 2, etc. All arrays start at 0. So that's a common mistake, is what's known as an off by 1 error. So just do a very quick look at what JavaScript allows for an array. This is what an array looks like. It's an open bracket, and then you can put whatever you want in there, even other arrays, and then you can refer to it by its index. So if I say R, you'll see 0 is S, 1 is 2, or 1 is 1, 2 is type, and 3 is an empty array. Sort of like most things, you don't want to go too far into it. This is what's known as a multi-indexed array or a multi-dimensional array. So we have this array, then we have an array inside of an array, and we keep going down further and further. But generally, once you get beyond 2 dimensions, 3 at most, it gets very tricky to know what exactly you're looking at, particularly with numerically indexed arrays, because you cannot refer to anything inside of there by a name. So everything's just 0, 1, 2. So here it would be R3, 0. And you can see that's not very descriptive. It doesn't tell you too much. And that just gets me nothing because there's nothing inside of there. Here, though, it gets me the first character there, and that's because a string is an array of characters, as we've seen before. So now let's look at it inside of our code here. I should have already added the debugger statement to my code, and we can see it right there. So we're going to see just what we saw above, just creating a basic array. We can put anything inside there. And sure enough, we expect whatever is at position 2 to be equal to 3, and it is. So 0, 1, 2, and then that gets us 3. Then we'll add ourselves a breakpoint right there. Using the push method, which is available on all arrays, you can add something to the very end of it. So you see here it was 1, 2, 3, and 4. When we added push, the 5 element got added right there, and that gives us an array length of 5. All arrays have a .length property attached to them, which goes back to JavaScript and primitives and how they're sort of quasi-primitives. Next, we can use pop and we can use push. Push adds something to the end of an array. Pop gets the last element off an array. This is a very common operation inside of arrays. And something important to note is these are what are known as destructive modifications. And in programming, a destructive modification means you change the state of whatever object it is that you're looking at. So whenever I call pop here, so I'm going to go through it. I got R, I create my elements, and then I go right here and I've got my remove value, which is 4. You can see right here I changed the value of the array. The array is now completely different and has a different set of elements than what I originally attached there. And then we saw the same thing happen up here. Now the array length is 1 less, so it's only 3. And by capturing the value, it returned it and placed it inside of this variable right here. So that remove variable is going to be equal to 4. Next, there is the shift and unshift operation, which puts things in the front of the array, and then it makes sure to push everything else down by 1. So it maintains the order of the arrays. And this is a much less common operation, but there will be times you're going to need to do something like this. So here I've created my basic array, and then I use shift, and you'll notice right there that it added 3 right to the front of it, and then it pushed everything else down. So when I look at it, everything else still maintained its numeric position. It just got pushed over by 1. So that's what unshift does. And then we test it. 0 is going to be equal to 3 right there. And then, of course, our length is also going to have changed. So this is also a destructive modification. Next, if we need to move something remove something from the front of an array, we only want to pop the first element off at the front. There's basically in programming what's called queues and what are called stacks. And the good way to think about it is that a queue is like when you go to the grocery store and you have that line there. The first in is the first out. And that's what this is creating. Then you have a stack, which is sort of like a stack of plates. The last one that you put on top of there is the last one out. So you'll sometimes hear people call these stacks or queues. That's what they're referring to, is whether you're grabbing something off the top or whether you're grabbing something off the bottom, and what order you're going to process the elements. So here, whenever I call shift, I'm going to remove that 1 right there, and we can see it there. Now we have 2, 3, and 4 in our array. It has destructively modified it, and thus I have been able to capture it inside of this particular value right there. And sure enough, 1 is going to be equal to 1, and the array length is going to have changed. Next, we're going to look at the splice method, and splice is another destructive modification. And what this is used for is, what if I need to remove not something in the very front or something in the very back, but I want to remove something at a very particular point, or I want to remove a list of points. So if I need to remove 2 or 3 elements, I can specify that in the argument right here. So here we have our array, and this one is what's known as a mixed array. That's if you take stuff and you put numbers, strings, characters, or whatever else, arrays, objects, inside of an array. So after I create that, I'm going to use index of. Index of works in arrays, sort of like how it does in strings. It's going to return the position of an element if it exists, or it's going to return -1 if that element does not exist at all. So here it's going to tell me that it's at position 1, so this is position 0. Position 1 has hey, that's what it returns. And then whenever I want to remove it, I'm going to tell it to splice that location and give me the first result back. So what you just saw right there in that transition is hey got removed, and it returned me a new array with that inside of it. And because I can return more than one element, this has to be an array element that gets returned back. If I try returning a string, for example, it could only return one thing back to me. And it has no guarantee inside of JavaScript what sort of thing is going to be returned to me anyway. So because of that, you always get an array back from this operation. So the hey location is equal to 1. The array length has now been changed, so that's going to be equal to 3. Then whenever I call the 0 element inside of my new array, that's going to be hey. And then once I remove it and I call index of on it, you're going to see that that's now going to equal -1 inside of this original array. And that's because that element has been completely removed. Next, we're going to look at copying elements of an array. So here we have our R, and that's going to set us up again. Just like before, we're going to get our index of so we know our location. And now we're going to copy it. So notice here that by using slice instead of splice, it copied the array, and the original array still has hey inside of it. So sometimes you want to do a destructive modification, sometimes you want to do a non-destructive modification. And that's what's going to happen here. So last time the array length was equal to 3, now it's going to be equal to 4. We're going to see that the copied array is pretty much the same, and that now, whenever we get the index of, it's going to be equal to whatever the original index of was, which was 1. So we don't get -1 or not found returned. Next, sometimes you're going to use an array to create a string, and that's basically whenever you're getting a list of arguments from a database or something like that. And so now you're going to have a whole bunch of different elements, and you're going to need some way of converting all those elements into a string. The join operation will do that for you. So when we take our array and we call join on it and we use a comma, that's going to convert it into from 1, 2, and 3 to 1, 2, 3. Notice if you don't add space inside of your join operation right here, so your join method. If there's no space here, you don't get any space inside of your string. So you have to pay close attention to what you're going to do there. Also notice the last element does not get that join operation performed on it. So you don't have to worry about having trailing commas or trailing spaces or anything. Next, we're going to look at the arguments. This is a reserved keyword, and what it does is what if I create a function and I don't know how many arguments that function is going to take? Well, I'm going to get something that's known as a pseudo array or an array-like variable. And this is one of JavaScript's kind of buggy practices that annoys people. But JavaScript has a reserved variable and it has a .length property on it. Now, it is not an array because you cannot use array arguments on it. If you attempt to do that, you're going to get a problem. That's why we looked at slice and splice above, because we can create a new copy of it, and with this new copy, we can modify it how we need to. So here we have first get arguments, which is going to tell us the length of any arguments that are returned, and then we're going to use SumAny using something you might see, which is a way to convert pseudo variables into proper array variables. So if you got a pseudo array and you need to convert it, you can call array.slice.call, and then you pass in the arguments there, and that's going to convert it into a true array. Next, all arrays have this reduce method, and if you do that, we're going to be able to sum it up. So here is what I would consider to be traditional JavaScript. This is more likely what you're going to see in most code. This is sort of the old school way of doing it. You create a sum total, you loop through all the arguments, and then you add up the arguments with the position of the index element. In the newer style, you're not going to see that. You're going to see it done like this, and I'll throw a debug statement so we can go get a look at it. So let's step through. So here we called the function getArguments. We passed in 3 arguments, and it returns the length back, and that means we had 3 arguments that were inside of there. Next, we're going to look at SumAny. We step into it, and here we see that first we start off with some sort of, and then we're going to for each over it, or just for over it. And then every single time it runs through, it's going to check the length, and it's going to check the value of I. So each time this runs through, I goes up by 1, and it's just going to keep doing that over and over again. And then eventually we're going to get the sum total, and that's going to be equal to 21. And the prototype version is going to call slice, and then it's going to call reduce, and reduce is going to take an array and reduce it down to a single string value. And here I'm taking the previous value and I'm equaling it to whatever the current value is. So each time it starts at 0, which is the argument right here, then 1, 2, 3, 4, 5, 6, and it returns that. Some people like this one because it's a little more concise, and the names that I'm giving things like flat and sum are easier to read than sort of right here. We have to kind of look at it and try to figure out what's going on. But both of these work exactly the same. So that's an introduction to arrays. There's a lot more you can do with them, obviously, but this covers pretty much what you're going to be doing. You're going to be pushing things to the end of the array, popping them off, and then you're going to be slicing and splicing them based upon if you need to get a particular object out of the array. So that concludes our look at arrays.